AR cube. I mean, there are different techniques are there for error controls, error detection process. I last told you, last class I told you, as usual, initials, etc. Positive acknowledgement by sending the acknowledgement, positive acknowledgement, it can be confirmed that all the frames have been received successfully, or it can be retransmissions after timeout. The say sending station can be equipped with a timer. When the time is out, when the time expires, retransmissions would be there. If there is no acknowledgement, the retransmission of the frame will be there. Using negative acknowledgement and retransmissions, by sending a negative acknowledgement. Also, the sending stations can retransmit if it receives the sending station, it receives the negative acknowledgement, then the source can retransmit that particular frames. And so collectively all the mechanisms are called the ARQ mechanisms. ARQ, automatic repeat request. Right. There are three ARQ mechanisms are there: stop and wait ARQ, go back in ARQ, and selective reject ARQs. So out of these things, most simple one is the stop and wait ARQ. So you see in first one, stop and wait. ARQ. In this case, you see it follows the same principle of stop and wait. Right. I mean, the source will transmit the frames, and it will wait for the acknowledgement, and if there is no acknowledgement, no further frame will be transmitted. When the acknowledgement received, then the frame will be transmitted. Two errors will be there in this case. There can be two errors, two kinds of errors will be there in such case. So it can be damaged frames, frame damaged. You see the frame that is transmitted by the sender would be damaged. The receiver detects by using some schemes, error detection schemes, and discards the frames. And the source will be equipped with timer. After the frame is transmitted, the source station will wait for acknowledgement. If no acknowledgement, frame is transmitted, and it will wait for frames. It will wait for ACK. If there is no ACK, you see, then it will wait. It will wait for the acknowledgement. If no acknowledgement is received, then by the time, if that time expires, then A will repeat the frames. A will retransmit the frames. Retransmit. A will retransmit the frames. Right. So, but in the process, the transmitter will maintain a copy of the frames until the acknowledgement is received. So it will maintain a copy of the frames until the acknowledgement received. That is the case. That is one error, right? Damaged frames. This is one types. There can be second type of error. That is the damaged acknowledgement. Acknowledgement damaged. These times the frame say frame received and B transmits the acknowledgement, but that acknowledgement is lost. Then A will also you see, since B has received the acknowledgement successfully, so it will send the acknowledgement, but that acknowledgement is lost. It's lost. So it is not lost or it is damaged. So A cannot recognize the acknowledgement. Then by the times when the A times out, when the time expires, it will retransmit the frames. But you see, since B has received the frames, so these times there will be copy of the frame will be there, but B cannot understand that whether it is the same one or different one. So generally B will understand it's a different frame. So since earlier frame is received successfully, so these times B will consider it's a separate frames. I mean, second station, the receiver will consider that frame as a separate frames, the new frames, but actually it is a copy of the previous frames. So that is the acknowledgement. If acknowledgement is damaged, right? So some duplicacy will be there. This problem can be avoided generally in stop and wait ARQ. You see, by numbering the frames, by labeling the frames. The frames are numbered. Frames are numbered by 0 and 1. Acknowledgement also are numbered as ACK 0. ACK 0 and ACK 1. Right? They are the positive acknowledgements. Right? Frames are numbered 0 once, frame 0, frame once, and acknowledgement also numbered ACK 0, ACK 1. And what are this meaning of ACK 0? Suppose it transmits ACK 0. That means it has received the frame number 1 and ready to receive the frame number 0. That is the meaning of these things. If it is ACK 1, that means it has received the frame number 0 and ready to receive the frame number 1. Right. If it with these things, this duplicacy, so this here the duplicate frame, this problem duplicacy can be avoided in this case. See how? See the diagrams, it will be clear. You see the diagrams. Suppose this is the frames. This is one frame, and this is a frame 0. And see, immediately it is generally not transmitted the acknowledgement when it is received. These ones. So some acknowledgement, this is the acknowledgement. Some time will be there to transmit these ones. So this is the ACK 0. So ACK will be there. So this is ACK This is ACK frame 0, so it will be ACK 1. It will be ACK 1. Right. Next frame will be transmitted. Next frame will be transmitted. Since it is frame 0, so it will be transmitted. This is F1. Right. So this is the this actually timing. If you just see, this is the frame transmission times. Frame transmission times. And if you see this this one, the propagation times. This is the propagation times. Right. So if this frame is received successfully, then you see again acknowledgement will be transmitted. This is the acknowledgement frame 1, so it will be ACK 0. ACK 0 means it has received the frame number 1 and ready to receive the frame number 0. So after this, again next frame will be transmitted. But this frame, say this is F0, so this is lost. So this is damaged, right? Then you see B will not receive B will not receive anything, but A if B is not sending anything, and A suppose it is equipped with timer, then you see after a certain times, certain time lapse, I mean that is set by the transmitter. If the time this is the time intervals, right? Time intervals. So after these time intervals, on the time expires, the same frame will be transmitted. Same frame will be transmitted. This is frame 0. So frame 0 again it will be transmitted. Right. So these times when we receive these ones, it will send the acknowledgement, corresponding acknowledgement. Right. Acknowledgement, these ones. So this is frame 0, that means it is ACK 1. It has received 0, ready to receive the frame number 1s. Next onwards again A will transmit. This is A, station A. This is station A and this is station B. A transmitter, B receiver. Right. So you see again this frame will be transmitted. This is F0. So next time will be F1. F1 is transmitted here, and B will transmit the acknowledgement again. Acknowledgement, but this time say this acknowledgement is lost. This acknowledgement, this is F0, this is F1, and this is acknowledgement, this is F1, so it will be ACK 0. So this ACK 0 is now lost, is damaged. Then what A will do? Then you see A is equipped with the timer. I'm just continuing this one here. The timer, say from here, the time interval is here. So these ones. So after certain time intervals, this you see A will repeat this the frames. Which frames? F1. Frame F1 will be retransmitted when the time expires. This time interval. This is the time intervals. After this time interval set by the timer, you see this frame again will be transmitted F1. right? F1, right? But this times you see there'll be no complication here. That is because B already received. We already received this frame 0. This is frame 1 successfully. So if another frame 1 it is received by B, that means it will understand this is duplicate frames and it will be discarded. So but acknowledgement will be sent against ACK ACK 0, ACK 0, but you see, but these frames, this frame will be discarded. ACK 0, right? Because this frames it is expected now frame number 0. So this duplicate frames, the B, these frames, this frame will be discarded. We discards these duplicate frames. Duplicate frames. So that problems can be avoided. You see, if the frames are numbered, frames are numbered as well as acknowledgements are numbered. Once again, you see now the you see noise is not there. Just quickly, I'm just once again stop and wait. This is the principle of stop and wait ARQ. So here you see frames are numbered. It's based on stop and wait flow controls, but here frames are numbered and acknowledgements are also numbered. If you do not, if the number labelings are not done, then you see duplicacy will be there, and then the same frame will be repeated. Right. So how it is being avoided? Say A transmits the frames F0 and B receives this once and sends the acknowledgement ACK1. ACK1 means it has received frame number 0, ready to receive frame number 1s. So after receiving this one, A will transmit this one F1s, F0 next F1s, and correspondingly B will transmit acknowledgement 0. It has received frame number 1, ready to frame number 0. Received is 0. But this time say F0 frame is lost, and after certain time intervals, you see time intervals. I mean A will be equipped with the timers. Then you see the same frames. There is no acknowledgement, so it will repeat the frame transmissions F0. So this times B will receive it earlier F1, so B will receive successfully and send the acknowledgement this ACK1, and the corresponding next frames will be transmitted by A. But this time say B, when B sends the acknowledgement, that is lost or that is damaged. So, in the previous way, when the time expires, the A will repeat the frames F1s. But earlier F1 is received by B successfully, and again F1 is transmitted, then B will understand the duplicate frames and it will be discarded. And the corresponding acknowledgement will be there, same acknowledgement will be repeated, earlier that is lost, and the next frames will be F0. So in that way, the error controls can be implemented using stop and wait flow controls. Have you followed these ones? Anybody? Any questions regarding this? If you have any question, you can ask. Have you followed or not? Just tell me. Have you followed or not?
Yes, sir. Followed, sir.
Okay. You see, the advantage of this protocol is it's very simple, but the drawback is it's quite clear. Each frame is received, next frame is transmitted. So it's a very slow process. Ineffective mechanisms. Efficiency is less, right? Right. So to avoid this one, as before, sliding window based frame transmission should be considered. So the next protocol it is that is the other two protocols are based on sliding window flow controls. So the most important widely used error control ARQ mechanisms, it is go back. Go back in ARQ protocols. Go back in automatic repeat request protocols, error control techniques. In this case, it is based on sliding window. I mean, all the frames, several frames will be transmitted at a time. Sliding window flow control protocols. Flow controls. You see here, one station can transmit a series of frames, and those frames are numbered sequentially. When no errors occur, if there is no errors, you see, try to understand this way. This is the most important one. No errors are there. No errors are there. That times, you see, the so if there's no errors, then the receiving station will send the acknowledgement RR. RR command will be there. RR just like acknowledgement RR. Say RR5. If it is RR5, that means it has received the frame number up to till frame number 4. I mean 0, 1, 2, 3, 4, etc. Ready to receive the frame number 5. So RR command will be there. If received successfully, if no errors are there. But if some error is there, particular frame is in error, that times the negative acknowledgement like REJ, reject, are ready to receive. RR means ready to receive. REJ means reject. This is the reject. REJ will be there. A particular, say, if it is REJ, here it is example, it is RR, say 5 just now mentioned. That means it has received the till frame numbers 4 and ready to receive the frame number 5 onwards. There is no errors, but if some error is there, then the receiving, the destination station will send the negative acknowledgement, that is REJ. Say if it is 5, then say it has the frame 5 is in error, is asking to repeat the frames. And in fact, by the times REJ5 will reach to the source stations, other frames also will be transmitted, because it is based on sliding window flow controls. So frame transmission will be there. After that means that is the reason behind it is you are getting the cumulative acknowledgement. It's a cumulative acknowledgement. Not that each frame is not acknowledged. Maybe 4 at a time, maybe 2 at a time, like this, like these things. So several frames, after several frames, acknowledgement may be received. So subsequent, but once the source station receives this reject 5, then it will send the source stations not only retransmit this 5 this frame number 5, but also it will retransmit the other frames that it has already transmitted, or all succeeding frames, right? So that is the principle of this sliding window flow. There's a little drawback is there, but this is the principle of it, these things. How it can be overcome, that we'll see it. Another protocol is here. So that is the principle of this, the go back in ARQ. So more elaborately, here several cases are there. You see, suppose just now I am saying what I am saying. So suppose A is A station A. It transmits, say, I-1 frames, and B receives this I-1 frame successfully, right? B received. Several cases will be there. In this case, that's why those things are to be clear. And what are the different cases? So next frames, A transmits I-1 the frames, right? And B received this I- received. And next frames, obviously, A will transmit these the ith frames, the frame number I, right? And now you see what the go back in these protocols, what it considers. It takes into account the following cases. Say case 1, right? there can be here also can be frame damaged, can be damaged acknowledgement. Those things are there. But how this go back in ARQ, how it takes into account those cases. So the case, if you see the damaged frames, this case 1, the damaged frames. There can be damaged RR, there can be damaged reject. These cases will be there. So we are considering the damaged frames. Case 1, damaged frames. There can be several sub cases will be there. Suppose damaged frame means the received frame is invalid, right? The frame invalid frame is received, invalid frame is received, and B discards the frames and takes no action as a result of this. Since it is invalid frames, so if B does not take any actions, then there can be 2 sub cases. Say sub cases will be there. Sub cases. This is case 1. Under case 1, there can be 2 sub cases. Number 1, you see, after a certain reasonable period of time, this how this can be overcomes. After a reasonable period of times, the A sends the acknowledgement, sends the next frames I+1s. Right, this frame will be transmitted. Right, this frame will be transmitted, and but B, what the B will see? B will see that this I+1 frames, this is out of order because it has received I-1s, right? And after transmitting I is getting this I+1, but it has not received the ith frames. So I+1 frames will be out of order. This will be out of order, right? And it will send the reject frames, the negative element, reject I. This acknowledgement will be sent by the destination station. Say destination station A, the sending stations, just I'm sending stations, and B, the destinations, receiving stations. So when B will see the frame, it is in out of order, so it will send the negative acknowledgement REJ. Then you see, but within this time intervals, not the out of the time intervals. So in that case, after getting this reject, this acknowledgement, negative element, A will transmit these frames I as well as other subsequent frame also. Not only ith frames, because after transmitting I, it will transmit the subsequent frame also. But those frames will be discarded by the B unless it receives the frames in sequence. So after transmitting after getting this acknowledgement reject I, A will transmit not only this frame I but also some other succeeding frames. So this is the sub case 1, and another case will be there, sub case 2. You see, sub case B. In this case, suppose A, the same happens. It will frame damaged, but A does not send additional frames. No frames transmitted. No frames transmitted. After that, the damaged frames are not getting an element. No frame transmitted by A. And so B also, it does not send any acknowledgement. No acknowledgement sent, either RR or reject. Right. No action is taken by A, and B also, A also not transmitting any frames. Right. This might happen. This is second case, second sub case. Or the first sub case, within the times, B can send the acknowledgement, negative acknowledgement, and subsequently A will transmit the damaged frames as well as which is framed, which is damaged, same frames on all other succeeding frames. Second case is after sending this, sending the frames, no acknowledgement is received by A, so no frames transmitted, and B also is not sending any acknowledgement. Yes. Go to the next. So next acknowledgement, no acknowledgement will be there. No acknowledgement is sent by B, either RR or reject, right? So by the time time expires, so time expires. The subcase 1 within the times, now the time expires. Nothing received and nothing transmitted, right? After the time transmissions, then what the process will do here, they go back in ARQ. When actually timer will be there equipped with the sending station. So A's time, A is equipped with the timer, and A's time expires. A's times expires. So when the time is timeout takes place. That times what the A will do, A will send frames which is called RR frames. RR with P bit, RR with P bit, RR with P, and then it's a command frames, and is set to 1, P bit equal to 1, right? If it is this, if this frame is transmitted RR with P bit, which is set to 1, then actually it indicates it's a command frames. It's a command frames, right? And command frames, and this when the logic is when this frame is received by the B, the destination station, it must be responded, right? So B will see it's a command frames, and after getting these things, it will send definitely send the acknowledgement to A with RR, RR frames, the RR with the no, RR, obviously acknowledgement means RR with the next frames you want to receives, right? Right. So RRI will be there. So RRI, because in this case RRI it is damaged, so it will send the RRI. That means it has received the I-1 till I-1s. It has not received these ith frames, and the subsidiary frames are not transmitted by A. So A will, after getting these ones, A will transmit the frame I, which was damaged earlier, and the subsidiary frames. Next frames will be transmitted, getting this acknowledgement. So this is the subcase. So here one thing is you see that is most important. RR with P bit, which is set to 1s. This is the subcase B. This is most important in go back in ARQ. Right. So this is the case 1. Under case 1, there are 2 cases are there. One within the time intervals, acknowledgement, negative acknowledgement received. Next case within the time interval, there is no acknowledgement. That means command frame will be transmitted by the sending stations. After getting these things, the acknowledgement will be sent by the destination, and the corresponding frames transmission will be resumed. The second case, this is the case 1. Now in case 2, you see in case 1 damaged frames. In case 2, there can be damaged acknowledgement, damaged RR. So here you see P receives the frames I and sends the it frame I received and sends the I and sends the acknowledgement RR. RR I plus 1, right? RR I plus 1. If the frame I is received, obviously RR I plus 1 will be there. That is the meaning of these things. It has received the till frame I and ready to receive the next frames, which is I plus 1, right? But this times this acknowledgement is lost or damaged. Then you see A will not take anything, will not take any action, because say A will understand, the sending will understand it will send some acknowledgement. Because you see each frames is not acknowledged in in sliding into flow controls, in request sliding into flow controls. So maybe next acknowledgement will be there. That will indicate the receiving of the earlier frames. Say it is not, say I told you, this RR, maybe RR5 will be there, right? Say RR, it is expecting say RR2, but RR2 is lost. But next frames, next acknowledgement may be there that is indicating RR5s. If that is there, that means it will send it's okay, but that is within the times, within the time intervals, right? Within these time intervals, this might happen within the time intervals because the acknowledgement is cumulative. So A will wait for the A can transmit. It will not stop the transmission of frames. It will transmit expecting the next acknowledgement within the time limit. Keep in mind within the time limit. So this is case 2. Sub cases is 1, right? Another sub case will be there. So here also damaged frames that can be okay. This is another damaged frames. This is sub case. This is sub case 1A, and another case will be there, and the sub case will be there as before for damaged frames. A time expires. This is within the times, within the times intervals, within the time intervals, right? But if the time expires, acknowledgement is sent and that is not received by A, and by the times A's time out, what will happen? The same thing will be there. The same things you see. A will transmit in this case in the same way as before. A will transmit RRP, RRP with set to ones, P bit set to ones, RRP and timer will be there. And that is a common frames. So B must respond it. If B fails to respond this acknowledgement, this command frame also to respond these frames, then A will repeat these ones. It will repeat this RRP. This frames again, command frame will be repeated, right? And restart the timer, right? So this procedure will continue after several times. Even that if A does not receive any acknowledgement after certain maximum number of attempts, then it will initiate the whole process. It will reset the whole procedures. So that is the case. There are the different cases for the damaged acknowledgement. Same thing as this is this subcase 2, same as the subcase 2 of damaged frames. The command frame will be the, but here see command frames here this it can be you see B if B fails to respond here this command frames, then A will try several times. After a certain number of times, then whole thing will be reset. Right. So that is the case for damaged acknowledgement. Similarly, case 3 also would be there. Case 3, that is for damaged. This is for damaged RR. That can be damaged. Another acknowledgement is here, there is the damaged reject. So the two types of acknowledgements are the damaged reject. Right. Here the same as this these ones, the damaged RR. The same thing as for damaged acknowledgement. This is another acknowledgement. The same thing will happen for this damaged reject. So all the things now let us see quickly in the diagrams. It will be more clear if you see it. What I mentioned, you see it here. say this is, I'm not showing this frame transmission times, this thing already known to you. Say F0, next F1. The slide into flow controls. Several frames can be transmitted at a times. Not each frame will be acknowledged. So frame once after receiving 2 frames. So this is frame once. So B acknowledges these ones. By the times this acknowledgement will be there, it will transmit. Now, can anybody suggest what will be the acknowledgement here? What acknowledgement here? If it is successfully, this is A, this is B. If anybody can you suggest what acknowledgement will be here? What I should write here? These things will be asked also in quizzes also, like these things. After receiving frame once, what the B will send here?
Sir, 1.
Now, which acknowledgement? There are 2 acknowledgements, RR and R reject. So which one will be transmitted here? There are 2 acknowledgements, you see, RR and reject, right? So which one will be transmitted here? B?
Sir, the second one, sir.
Which one?
VZ, sir. Second one.
No, I mean, see, 2 acknowledgements, the RR and REJ. The RR means positive acknowledgement. It received successfully. Next acknowledgement say what it received. Reject means the frame is damaged and negative acknowledgement. So what the B will send here? This acknowledgement?
Sir, RR.
RR, what will be the number?
Sir, RR1.
No, that's the wrong one. No? That's why I mean this will be RR2. You just see it, RR2 means it has received the till frame number once and ready to receive the frame number 2. That's what I mentioned. You see it here. I told you here RR5 means it has received the previous all frames up to 4, ready to receive the frame number. Which frame it wants to receive? That is the number. It is not received. Am I clear now? This will be RR2.
Yes.
RR2 means till 1 it has received. Okay. By the times it will reach here, A already transmitted frame number 2, right? This will continue, no problems, right? So it's a cumulative acknowledgement. This slide into flow controls, right? So this will continue. Say it receives, there will be no stopping of these frames. It will continue. So next frames will be F3. Next, say suppose this times B sends the acknowledgement. So F3. So okay, first consider the damage frames. So F3, so it will send say acknowledgement. Say it can send the acknowledgement. Say RR 3, that means RR4. By the times RR4 will reach here, it will transmit and another frames. That is it transmitted F0, F1, F2, F3, then F4. Next will be this will be F4. But that frame select is lost. That frame is lost. So, but A will transmit, continue to transmit these frames. This is F4. This is the acknowledgement. You see, this arrow indicates this is the acknowledgement. RR4. So, so next frames will be transmitted. You see RR4. So next frame F3, F4. So but it has not received. So you see it will transmit F5. RR4 is received. So it will transmit the F5. F4 next will be F5. Will be transmitted. Not only F5, it also transmit the F6. The subsequent frames will be transmitted. You see F4. It is received these ones. F5, F6. It is sliding in flow control. It is not transmit one frame. Several frames will be transmitted. But you see what the B will see. Carefully just see it. B will see that the frame, this frame 4 not received, but the frame 5 has been received. Frame 5 and frame 6, they have arrived. So it will discard. It will discard by it will be discarded. This will be discarded by the destination stations. And once it gets this frame number 5, then it will send the negative acknowledgement. Right? It will send the negative acknowledgement, that is reject REJ. Which frame it is reject? Which frame is not received? 4. It is 4. So 4. So after getting this reject acknowledgement, this reject 4, A will again retransmit. A will retransmit the frame, not only this frame 4, but also it will transmit this frame 4, but also it will transmit this frame 5 and frame 6. F5, F6. These frames will be transmitted. Right. So that is the case here. And so after getting this F6, you see next acknowledgement will be there, say RR. And this time, now it is quite clear. Next will be RR7s. We will just anyway. Up to this is the frame damage. We have seen it. Next time I'll just show you. This time is over. Try to go through it. Next time it's also the how if damaged RRP bit. If how the command frames being transmitted by the sending stations, how it is responded by the destination. Next time we'll see it. We'll go through it. These are most important. This is the most important product out of the 3 protocols. This is the most, and the present day internet is based on these things. Just a minute. I'm just stopping. If you have questions, next time you can ask.